Okay, today we're actually going to be working on equations that'll have variables on both sides. So here's our first example. You have a choice. You are going to be isolating the variable, and you'll be moving the variable terms to one side of the equal sign and the constants to the other. So in this case, since we have 5x on the left and on the right we have 3x plus 12, it would be one step if we just move the 3x over to the left-hand side. So we'll undo or use the additive inverse, and we'll subtract 3x from the right, which means we're going to also subtract 3x from the left. Since this is gone, 5 minus 3 is 2x, and we bring down the constant. Now we just simply divide both sides by 2, and we get x is equal to 6. To check our work, 5 times 6 will be equal to 3 times 6 plus 12. So 30 will be equal to 18 plus 12, and since 18 plus 12 is 30, we know that our solution is correct. Okay, example 2. In example 2, we have 28 minus 5m is equal to 2m. So let's go ahead and move the variable to the right this time. So if we add 5m to both sides, we'll get 28 is equal to 7m. We'll divide both sides by 7, and we'll get 4 is equal to m. So again, we can check our work using order of operations. So 28 minus 20 is equal to 8. 8 does in fact equal 8. Okay, in this situation we have constants and variables on both sides. So you're going to find one or the other way that you like to solve these the most. Some people will always subtract the smaller coefficient from the larger coefficient with the variable term, not caring whether it's on the right or left. Others will always move variables to the left. I happen to be one of those. So I like my variables on the left. I will move 4g over to the left hand side. So 7 minus 4 is 3g minus the 23 is equal to 52. So I will add 23 to both sides. Bring down my 3g. It's going to be equal to 75. If I divide both sides by 3, I get g is equal to 25. And again, I have to go back to the very beginning. So I'll take 25 times 7 minus 23, and that would be equal to 4 times 25 plus 52. So 7 times 25 is going to be 175 minus 23, 100 plus 52. And if I take 75 minus 23, I get 152, and it checks out. Let's try a few more, just so that you can get the hang of this. So remember that in a multi-step equation, we want to first clear the parentheses. So we'll distribute the 9 on the right-hand side. 3d is equal to 9d minus 9. And so I'll go ahead, not even worrying about the negatives. I'll subtract the 9d from both sides. So we'll get a negative 6d on the left is equal to a negative 9, and we'll divide by a negative 6 on both sides. And so our answer is going to be positive. It'll be a positive 3 over 2, which is equal to 1 1/2. So if I'm going to, I'll probably leave it improper to do the math for the checking. So 3 times 3/2 should be equal to 9 times, actually I'll go ahead and keep the distributed property part, 3/2 minus the 9. So I'll have 9/2 is equal to 27/2. And if it's going to be minus 9 and I want to write it with a denominator of 2, it'll be 18 right here. So when I take 27 minus the 18 on the right, I get 9/2, and I know that my math checks out then. So that's one way to do it if you have fraction solutions. Okay, again, let's get the distributed property going. So 4 times -2 is -8. 4 times 3x is a 12x. And when I start thinking about moving that variable term, something shouldn't look right at this stage, because I'm not sure how on the right-hand side I could have 12x, and on the left-hand side I can also have a positive 12x. And this is a statement of equality, plus the -8. It's kind of out of balance, right? There's no way that 12x can be equal to 8 less than itself. So you'll find if I try to move the variable, you'll see what'll happen, because at the constants on the left, I'll subtract 12x from both sides. Okay, and I get -8 is equal to 0, and that is not a true statement. So in this case, there is no solution. Okay, now we can get x is equal to 0, or y is equal to 0. Having something equal to 0 can be a solution, right? But if you get something where the variable is eliminated, then you'll have no solution. So watch out for those. Again, use distributed property for example 6. So 14x plus 21 is equal to 21 plus 14x. Well, that looks like the commutative property of addition, and it is true. For every value of x, it will be true. So that means that when we get to this point, and I can show you what it looks like if we did try to solve it, this is all solutions, but let's just say we didn't figure that out yet. So let's try moving the variable to the left. Okay. And this is gone. So 21 equals 21 is obviously true. So every value of x. So the answer here that you would give is all solutions. And finally, we're going to watch a short video, and again, it's not necessary to take notes, but just listen and let it all absorb and think about everything that you've learned about today.
In this lesson, you are going to learn how to solve equations with variables on both sides by using inverse operations to collect like terms across the equal sign. As a reminder, our goal when we want to solve an equation is we want to find the value of the variable that makes both sides of the equation equal. We're going to do this by isolating the variable, getting the variable by itself by using inverse operations. We're going to do inverse operations to both sides of the equation, and every time we do an inverse operation, the equation should be even more simplified. To do this with variables on both sides, we need to review the concept of collecting like terms, or combining like terms. Like terms are same variable and same exponent. So if you look at our example, 2x plus 3x is 5x. same variable, and their exponent is 1. 7x minus 12x is negative 5x. 4 minus 10 is negative 6. These are both what we call constants, since they don't have a variable. And 2x plus 9, well, these aren't like terms. So 2x plus 9 is actually 2x plus 9. When we solve equations with variables on both sides, what we're really trying to do is get the terms with variables on one side and the constants on the other. We don't want to come across an issue like this where we're trying to combine things that aren't alike. I'm going to explain the idea of solving equations with variables on both sides by looking at equations where a variable was only on one side. This is what we've done up to this point. If you look at the two equations I have here, in the first one, the x, this highlight here, was on the left side, so we moved the constants to the right. We subtracted 8, inverse operations. On the second equation, we have an x here on the right side, so what we did was we ended up moving the constant, in this case a positive 5, by subtracting 5 to the left side. When we have variables on both sides of the equation, we need to decide what side we're going to put the variable on and what side we're going to put the constant on. Essentially, using inverse operations, we're going to combine or collect like terms. There's two ways of doing it. I'm going to show you the first way, which is popular option 1, where we always move the variable to the left side. So in this case, I need to move the 5x over to the left side. So I'm going to use inverse operations. The inverse operation of 5x is minus 5x. And I'm going to put it over with the 2x because they're like terms. Again, when you add and subtract, you can only combine like terms. So we're going to cancel these out over here. And then we're going to get 2x minus 5x is negative 3x. Bring down the 9 plus 9 equals negative 6. So again, I've moved my variable to the left side. Now this is a problem that you've seen before. We want to move the constants to the right side. In this case, the plus 9. The inverse operation of plus 9 is minus 9. So again, we're going to cancel these out here. Negative 3x equals negative 15. Divide by negative 3, because the inverse operation of multiplying on negative 3 is dividing negative 3. And we get x equals 5. So again, in the first option, we move the variable to the left side. In this second option, what I'm going to do is I'm going to actually move the variable to the side of the larger coefficient. People like to do this if they don't like to deal with negatives, because you tend not to deal with as many negatives when you do this option. So let me demonstrate. We have a 5x over here on the right, and we have a 2x on the left. 5 is larger than 2, so I'm going to move my variable to the right side. I'm going to do that by subtracting 2x to both sides of the equation. I get 9 equals 3x minus 6. Again, my variable's on the right side, but I'm not dealing with as many negatives. Now, since I moved my variable on the right side, I'm going to move my constants on the left. So I'm going to add 6 to my inverse operation. And then I get rid of those 6's over here. I get 15 equals 3x. 3 times x, inverse operation is division. Divide by 3, x equals 5. If you look at the two options, you see that both get the right answer of 5, but it's really a matter of personal preference. In the first option, you just always move the variable to the left side, since that's where we tend to see it. In the second option, you move it to the side of the larger coefficient, because that way you don't have to deal with as many negatives. It really is what you decide. So now you know how to solve equations with variables on both sides by collecting like terms on each side of the equal sign.